Okay, so let's jump into our notes. So Module 1 summary. Our goal for this little note section is to review and practice our 4 inverse models. So there are 4 ways we find inverses. We are reviewing and practicing these 4 ways. The first one is solving, and I feel like you guys have gotten really great at solving. So here are my steps to solving. Hopefully you guys have your own set of steps, but the way I think of it is to isolate the x to one side, so solve for your x, and then swap the x and y variables. If you prefer to swap the x and y variables first, that's awesome. Go for it. So let's try these 2 examples. Here's a linear example. We're going to solve for x and then swap the variables. So this is a pretty basic one. It really only has 2 steps, but I wanted to show you this one because the negative can sometimes be tricky. Start by subtracting 7 from either side. And then what do we do with that negative? I am going to divide both sides by -1, making sure I'm dividing the entire side by -1, not just the y or just the -7. And that actually divides each term individually by -1, making this a -y plus 7 equals x. And that's just one step away from our inverse. Our inverse is just saying, well, this inverse would then be y equals -x plus 7. So let's try the quadratic example. In our quadratic example, same thing. We're going to start by adding the 3 to both sides. I'm still trying to get into this x right here, but there's still plenty of stuff around it. That 4 on the front and the square are both things I need to undo first. Let's start with dividing out that 4. And again, that 4 is divided to both the y and the 3, not just one of them, so I'm going to keep it all together. Now I can take the square root of both sides. And the nice thing is that I can take the square root of the numerator and the square root of the denominator. So the square root of the numerator just stays y plus 3. But I know what the square root of 4 is. It's just 2. So now just subtract 1 from both sides to get that x completely by itself. And I'm going to rewrite this as 1/2 so I don't have to keep writing that big fraction everywhere. It means the same thing. And then I think we have our inverse. Y equals 1/2 x plus 3 minus 1. Oops. Okay, questions on quadratics. I know that seems to trip you guys up a lot. You make some little mistakes on quadratics. Okay, let's try this exponential equation because again, this is the tricky stuff right here. So we have this exponential function, which means the only way to find the inverse is a log. So let's start off by changing it into a log. Log base 3 of y equals x plus 5. Again, log base 3 of y equals x plus 5. We're still getting that x all by itself, so let's subtract the 5 to the other side. And that is kind of by itself. We already did the log, so the 5 is on the outside of the log. You don't necessarily need to write the parentheses, but I want to show you that the 5 is after the log. So now if we want to actually just write the inverse, we're switching the x and y equals log base 3 of x minus 5. So I think solving can sometimes be the trickiest, which is why I started with it first. But here are 3 examples: linear, quadratic, and exponential. Hopefully you can give yourself, well, you can feel a little bit more confident in solving, because that's kind of the most technical aspect of what we've done. Okay, maybe guys just a moment, and then let's move on to graphing. Okay, graphing. 2 examples for graphing. One of them is quadratic, one of them is exponential. You guys hit the nail on the head when you told me that you find any points on the original function, swap them, x, y becomes y, x. My last step to you would be to actually just double check, does it look like a reflection over the line y equals x? Does it actually look like it's mirrored over this line? So let's go ahead and let's try this. So let's see, we're going to start with our quadratic function. This point right here is over 2, down 2. So 2, 2 would then become back 2, up 2. Remember, we switch the x and y. And already that is looking like a mirrored point. That looks direct the line y equals x. This point is positive 1, negative 3. So it becomes negative 3, positive 1. The other point is 1, 2, 3, positive 3, 1, 2, 3, negative 3. So that one would become negative 3, 1, 2, 3, positive 3, 1, 2, 3. And I'm already starting to see my parabola fill in. And yeah, it does look like a reflection. So this next one is 1, 2, 3, 4, 5, 6. So that's the point 0, negative 6. That becomes negative 6, 1, 2, 3, 4, 5, 6, 0. And if you guys are familiar with parabolas, we know that every point is mirrored. So I know there's going to be a negative 6 point just on the other side, and that would match up with that point right there as well. Cool. Does that look like a mirror image to you guys, except for the fact that my parabola is super wonky? Let's try that again. It's a little bit better. Let's do the same with the exponential. I'm going to start with the easiest point I can see, and that's that one right there, which is 0, 1, 2, 3. 0, 3 will become 3, 0. This point right here, over 1 up 4, becomes over 4. Whoops, over 4 up 1. This point right here, over 2 up 1, 2, 3, 4, 5, 6. Over 2 up 6 becomes over 6 up 2. This point's a little harder to nail down, but it is negative 1, and it looks like it's up 2.5. So that means we're going to go over 2.5, 1, 2.5, and down 1. Yes. So Ellery asked a really great question. This right here is not a function. Sorry, I'm breaking from the other one. This is not a function. A follow-up question to this one would be, give me a domain or restrict the domain to make it a function. So that would be a follow-up question. I would have to ask you specifically to make that a function. So I think we have our logarithmic function right there. Now, if you wanted to test yourself and solve for this inverse, this is what the inverse equation would be. Again, if you wanted to kind of test yourself. And on this one, it would be log base 2 of x minus 2. But this one wasn't a solving, it was just a graphing. Okay, so we know solving, we know graphing. I'm going to give you guys a moment. We're going to move on to tables. So I'm going to mix it up a little bit, and instead of saying just swap the table, I want you to verify that these are inverses with a table. So that means we're going to create a table for the function and make sure that it works. Create a table for the function, make sure that it works. So we're going to start by creating this table over here. When it says create a table, it just means take these values and plug them into the function. So let's do that. And I am totally going to talk out loud as I do this. If you guys don't like that, maybe like just kind of tune out or mute it for a moment, try the table on your own, and then turn it back on. So this is the square root of 0 plus 1, which the square root of 0 is just 0. So that's 1. This is the square root of 1, which square root of 1 is just 1. So that's 2. And you know what? I think I want to make nice round numbers. I like the square root of 4, and I like the square root of 9. So I'm going to change those. Is that cool with you guys? Yeah, I see some nods. Square root of 4 is 2. So 2. Square root of 9 is 3. So 3 plus 1 is 4. Let's verify that these are inverses. So when I plug in 1, when I plug in 2, when I plug in 3, when I plug in 4, I should get out these values. If I don't, they're not inverses. If I do, they're inverses. So let's start plugging those values. Again, we're going to plug these values into that equation. Again, if I get those exact values back, these ones right back, cool, we have inverses. If I don't, they are not inverses. Okay, so let's plug in 1. 1 plus 1 squared is 2 squared, which is 4. Uh-oh. 2 plus 1 squared is 3 squared, which is 9. Uh-oh. 3 plus 1 squared is 4 squared, which equals 16. What are you guys thinking? One, 4, 0, 1. 2, 9, 1, 2. Yeah, they're not inverses. So that's just another way we can use those tables. We expect to see the tables perfectly inverted. When they're not inverses. Okay, I'm going to give you guys just a moment, and then I'm going to do another example of compositions. After this example of compositions, you guys are working on your own to just practice anything you can and ask questions. But stick with me through this last example of compositions. This is that new stuff we've practiced. It's still a little bit tricky. Okay, and I will post these notes after class. So if you missed something, look for a PDF or image of these notes posted. Great question, Megan. I chose these values first. Whoops. I chose these values first because I wanted to be able to take the square root of like really clean numbers. You could have chosen any numbers you wanted, anything. You could have chosen any numbers you wanted as long as when you swap, they're the same. I just looked at the square root right here. I looked at that square root and thought, well, I know numbers that will square root nicely. Like I didn't want to take the square root of 2. It's 1.4 something, and I didn't want to have to like plug that into this function. That would be weird. Okay, compositions. The whole idea is this is another chance to verify. It's another chance to verify. We can substitute each function into the other function and verify that it simplifies to x. So I'm going to start off by taking that first one, which is, whoops, sorry, wrong pen, f of x. But instead of plugging in x, I'm going to plug g of x in the middle of it. And remember, that should equal x. It should equal x. So let's figure that out. What is f of x? It's 1/2 x plus 4. But we're not plugging in x this time. We're plugging in g of x. So what is g of x? 1/2 2x minus 8. Okay, let's distribute that 1/2 into the parentheses. That 1/2 times 2x leaves me with just x. That 1/2 times negative 8 leaves me with negative 4. And now we have negative 4 and positive 4, which equals 0. So this does just equal x. So we got half of it down. Let's see if the other half works too. Now I'm going to move this down really quickly. Okay, let's see if the other half works. So we want to be able to take g and plug in f of x and have it still equal x. And have it still equal x. So what is g? G is 2x minus 8. But we're not going to plug in just x. We're going to substitute the entire value, f of x. So that means we're going to do 2 times all of f of x minus 8. F of x being 1/2 x plus 4. So let's distribute that 2 into the parentheses. That becomes 2 times 1/2 x is just x. 2 times 4 is 8. And 8 minus 8 is 0. So yeah, these are inverses. These are inverses. So we were verifying that they're inverses, and we were able to confirm, yes, they are inverses. Okay, these are the 4 ways we've learned about inverses. We've learned solving, we've learned graphing, we've learned tables, and we've learned compositions.